Right, the tractability section of the assessment you're doing. Some people did a reasonably good job, but there's a bit of scope for everyone to do a bit more. There's an extra opportunity because now on the computer science field guide page there's this new calculator which is much better and helps you to understand what's going on. And in fact, pretty much the entire assessment, a good report could be done just from this calculator. What you need to do, of course, is tie it in with what you've already done with the travelling salesman problem or the cray pots or whatever. But I'm just going to go through the main points that you need to be getting out of this. So at the moment we've got it set to the n squared level of complexity, which is not very complex. And if we had 10 items and we're doing some kind of algorithm that takes n squared to complete, it takes 100 seconds. But that's only if we're doing one operation per second and if we've got one processor. So of course one operation per second, not even the slowest computer ever was that slow. So we're just going to up it a little bit to say 1 gigahertz computer. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 1 billion operations per second, which is a lot closer to what a computer can actually do. So n squared takes 0 seconds for 10 items. So let's just bump that up a little bit to like 1,000. And still not very good. We might even need to go down to microseconds. So it takes 1,000 microseconds to complete that much. Now here's the critical thing. It's not about how long it takes, it's about how it increases as we increase the size of n. So if I go up to 1001, it goes up a bit. 1002 goes up a bit. It's not going up by a dramatic amount each time. You can do the maths on exactly how far it is. We're still at 0 seconds. So if I go to like 1,000,000, that's 1,000,000, 1,000,000 items that we're going to sort, 1 billion operations per second, n squared, 1,000 seconds, and again, it's really not going up very fast as I increase the number of items. So let's just switch over to n squared, n cubed, n to the 4, n to the 6. They're all polynomial, so they'll all behave pretty much the same. They go up a bit faster, but not too much. Let's go over this side to the 2 to the n factorial. Just to prove a point, I'll go with the n factorial. So let's bump it right down back to 10 items again, and we'll go with n factorial. 0 seconds, that's fine for 10 items. So we'll bump it up a touch. 11 items, 0.04 seconds, and this is the critical moment. 12 items, 0.48 seconds. 13 items, 6.23 seconds. It's more than 10 times faster each time. In fact, that was 13 times faster, I guess. So as we bump it up just by 1 each time, instead of getting a 0.001 of a second added on each time, we're adding on huge amounts, and our numbers are getting way out of control. And say we get up to 20, and we need to flick into, oh, not even days, we need to flick into 77 years. Oh, wow. Now, of course, we can get a faster computer, so we could say let's have a computer with lots and lots of processors. Maybe 1,000 processors would be good. That's good. We're down to less than 1 year, and maybe, you know, a 1 gigahertz computer is pretty slow these days. We'll go to a 10 gigahertz computer. Oh, we've managed to get it right down. So by getting a much faster computer, we've got it right down for 20 items to a manageable time. But here we go, 21 items, 22 items, 23 items. Wow, way out of control. So the whole point of the tractability problem is not how long it takes to do, but how quickly the problem becomes unmanageable as we increase the size of the problem. That's the idea that you need to get across in your report. This calculator is a great way to do it, using graphs, and ideally tie it in with what you've done already.